Hey guys, it's 101 Crunchy here. What's that? Okay, I'm back. Hey guys, it's the Midge Freezer. Hey guys, it's 101 Crunchy here. This is the science lesson 2, second part reading. I forgot to read the first one reading, so I'm very sorry about that. So pretty much we're right around, it says, in order for current, actually no, I think I read that. We're right here. It's on page E87 if you have a textbook, so I'm just going to read, right? Enjoy. When two or more electric devices are part of the same circuit, they can be connected in two different ways. In series circuit, the devices are connected in a row. There is a single path for the current, and it passes through each device on its way to the next device. When devices are connected in the series, they cannot be switched individually. Any switch will break the entire circuit and turn off all of the devices. If one of the devices breaks, it acts like a switch and also turns off all the other devices in the circuit. In a parallel circuit, each device is on a separate path. The current does not pass through one device to get to another, and each device can be switched separately. The energy traveling to one device does not depend on any other device being turned on. Electromagnets. In the investigation for this lesson, which we have not done yet, but we might be able to do, you discover that moving a magnet through a coil of wire produces an electric current in the wire. The reverse of this is also true. An electric current moving through a wire produces a magnetic field. If the wire is coiled, the magnetic field is concentrated in the center of the coil. The more loops in the coil, or the stronger the current, the stronger the magnetic field, which I actually learned about today. If a piece of iron is placed inside the coil, its magnetic domains line up the magnetic field on the coil and straighten it. The coil and the iron make up an electromagnet. A magnet run by electricity that can be turned on and off. Generating electricity. We're just on E88. And here we go. Huge amounts of electric current are generated by use of the same principle that you followed in the investigation. Most generators that provide electricity to homes and businesses are made with large coils of wire that rotate in very strong magnetic fields. Electric current is generated in the coils. There are several common sources for the energy to turn the coils of wire. In a windmill, the kinetic energy of the wind is used to turn a turbine that turns the coil. Most generators, however, rely on the potential energy of fossil fuels. When the fuels are burned, the energy is converted to heat that is used to boil water. The pressure from the steam turns a turbine, which then turns the coil on the generator. The diagram on the previous page shows a hydroglyphic, I think it's a really big word, energy station. It uses the energy of moving water to turn on a turbine. Summary. In certain substances, atoms with electrons that produce a magnetic field gather in magnetic domains. An object in which these domains are aligned is a magnet. An electromagnet is made when wire carrying an electric current is coiled around an iron core. When a wire is moved with a thin magnetic field, an electric current is produced in the wire. Electricity can move only through a closed circuit. Electric devices can be connected in a series circuit or in a panel circuit. And that's all for lesson 2. Okay, so in this lesson, what you can concur that you learned, I learned is that we learned about electromagnets, we learned about magnets, electricity, electric energy circuit, and electromagnets, and magnetism and stuff. So one thing I think, if you want to make some notes, is the north and north cannot connect, and neither can a south and a south. However, a north and a south can connect, and a south and a north can connect, and a north and a south can connect, like we said. Also, I think, you should maybe copy down the definitions if you are trying to, like, if you wanted to study for something or you just wanted some more information on this. And I really think I'm gonna, like, it's like, okay. So, I think that's pretty much it for this lesson. Sorry if I wasn't very energetic. It's a little late, so I'm kind of tired. So I promise I'll be more energetic tomorrow. Alright. So, tomorrow we'll be starting lesson 3. And it will be on page E91, called Energy from Compounds, Molecules, and Atoms, which we'll be starting tomorrow evening. Or tomorrow sometime. So thank you very much for watching my video. I hope you liked it. And remember, it's never too late to learn. So thank you very much for watching my video. I'm 101 Crunchy signing off for part 2. See you tomorrow.